Hey all, so today I'll be doing the 2024 Specialist Maths Exam 2, the multiple choice questions, because I figured I haven't done them yet. So let us get started with this. So question number 1, consider the statement this: for any integers m and n, if m plus n is greater than or equals to 9, then m is greater than or equal to 5, or n is greater than or equal to 5. The contrapositive of this statement is, okay, so contrapositive meaning that or will become and. Okay, so we can clearly cancel options A and B out because they still have or. And contrapositive will basically be m is less than 5 and n is less than 5, so then m plus n has to be less than 9. Yeah, so option C should be the answer for this question. Okay, so question 2, so consider the function f with the rule f of x equals to this. Which of the following statements is correct? Okay, so the function f is continuous, has a vertical asymptote, horizontal asymptote. The graph of y equals to f of x has a point of discontinuity. Okay, so what I'm going to do, I'm going to define the function on CAS and we'll go from there. So define and then f of x equals to, we're going to go to this one right here, and we'll have x squared plus 3 times x take away 10 divided by x minus 2, and the domain is x can be anything but 2, so x can be less than 2 and x can be greater than 2, but x can't be 2. So, and then the other one is just 7 and x equals to 2. Okay, the other thing that I was noticed as I typed this, as I defined this, is the fact that this is a quadratic and this is a linear, so we should be able to successfully divide this function. So okay, that's just a straight line, so x plus 5. So x plus 5, the linear line, has a domain of everything but 2, and at what happens at, so at x equals to 2, this line would return a value of 7, right? So, but since the x equals to 2 is not defined here, that means x cannot, so that means f of x cannot be 7 according to this function over here. But to fill that gap, or the discontinuity I should say, is 7. So it's at x equals, so y equals to 7 when x equals to 2, which is indeed what this would give us when we substitute 2 in. So at the end of the day, the function is going to be continuous, right? So what happens is, let me just quickly draw a picture or a graph. So we have this line like that, okay? And what happens is there is a discontinuity right here, for example. And let's say that this is our x equals to 2, okay? But it also says that so x equals to 2, y is equal to 7. So basically that fills the gap in again. So that means all we really have is just one continuous line, basically, like that, without any discontinuity. And of course it wouldn't have any asymptotes either, so it can't be options B, C and D, so answer is going to be A. Okay, hopefully that made sense. So the question 3 is the graph of f of x is equals to this, where h could be all real numbers, will have no turning points when. Okay, so in that case, again, I'll define the function on CAS, find the turning points in terms of h, and see what we can do. So define f of x equals to x minus h over x plus 1 times x minus 4. Okay, and let's find the derivative. So menu for 1 f of x, solve that when x equals to 0. Okay, not x equals to 0, I mean y equals to 0. So these are our stationary points in terms, like the x coordinate of the stationary points in terms of h. So if I want to make them undefined, because we don't want any turning points, so we have to basically make both of these undefined essentially. So what happens is, if you notice that there is a square root, meaning that if I make the square root undefined, then the whole thing will become undefined, and the square root term is the same for both of these. Okay, so technically all I have to really do is make this quadratic expression of h less than 0, because if this is less than 0, then the square root will be undefined and therefore there will be no solutions, right? So let's solve for that h term, less than 0, comma h. So as you can see that this should be our domain for having no solution. So let's see if it matches anything here. So the closest option I see is option C, but it does have an including sign. So -1 less than or equal to h less than or equals to 4. But we don't have that. So what happens when f of x and h is equals to -1? So that shouldn't have any solutions either. So if I were to differentiate this, yeah, so when h equals to -1, we have a hyperbola, and it doesn't have a turning point, because if I differentiate it and set it equals to 0, yeah, doesn't have any stationary points. So that means including does make sense, right? What if I put h equals to 4 here? X plus 1. Again, it won't have any stationary points because it's a hyperbola. So the answer is going to be C for this one, okay? Hopefully that makes sense. So next question. So question 4, given that sine x is equals to a, where x belongs to this, then cosine of x on 2 is equal to. So in that case, I can use the trigonometric identity that sine squared of x plus cosine squared of x is equals to 1. So that means a squared plus cosine squared of x equals to 1. So cosine squared x is equals to 1 minus a squared. Okay, so cosine x would be 1 minus a squared. Oh, plus or minus, of course. Now, one thing is, look at the domain. So this is basically saying that we are in quadrant 4, right? So if I were to draw a unit circle, like that, where is 3 pi and 2? 3 pi and 2 is here, and 2 pi is here, right? And our x is between that. So that means we are looking at this quadrant over here, and which is quadrant 4. Now what happens to cosine in quadrant 4? Well, cosine is positive in quadrant 4, right? So in that case, cosine of x is equals to 1 minus a squared. We'll take the positive root. Okay? Now, cosine squared of 1 on 2x is equals to 1 on 2, 1 plus cosine of x. And this formula is given, okay, in the formula sheet. So if you go to the very last page, the very last formula in that table is going to be this formula over here. I've just substituted a is equals to a half, okay? Nothing else has changed. Alright? So then our cosine of x on 2 is equals to plus or minus square root of 1 on 2, 1 plus cosine of x. And cosine of x we know is square root of 1 minus a squared, so let's substitute that in. 1 minus a squared. Now again, if we were to look at the domain, right? So our domain for x is 3 pi on 2 to 2 pi, right? Our domain for x on 2 will become, we have to divide it by 2 as well. If you're dividing the x by 2, you have to divide the domain by 2 as well. So it will be 3 pi on 4 and pi. Now, what region is this on the unit circle? It's going to be the second quadrant, right? Because 3 pi on 4 is somewhere here, maybe, and pi is here. So we are where? In the second quadrant. So we are in the second quadrant. Well, it's not going to be the whole region. Well, it's going to be this region over here. So yeah, 3 pi on 4 and pi. Okay? So since we are in the second quadrant, what happens to cosine? Cosine is negative. So cosine is negative in the second quadrant. So therefore, we'll take the negative root. So cosine of x on 2 is equals to minus 1 on 2, 1 plus 1 minus a squared. Okay? Now let's see which options actually match that. So, okay, they have written numerator and denominator separately. So we can write this as negative square root of 1 times, well, if it's just 1 time, it's just going to be itself. So 1 plus square root of 1 minus a squared divided by square root of 2, right? So this and this are the same thing. Okay, and let's see if that matches anything. Looks like option A. Okay, so next question. If the point is z equals to this, represented on an argand diagram, the point representing negative z bar can be located by, so negative z conjugate. Okay, okay, in that case, let us draw the grid and label the points to see the visual. Okay, so our z is somewhere here, 1 plus root 3i, so that is our z, 1 plus root 3i. And if I were to do negative z, or maybe I should do z bar first. So if I do negative z bar, it would just reflect, right, like that. So that would be z bar would be somewhere here, for example, and that would be 1 take away negative root 3i. Okay? And then if I want to find the negative of the z conjugate, we'll have negative 1 minus root 3i, which is just negative 1 plus root 3i, right? And that will be somewhere here, right? So negative z bar, right? So we have to simply reflect, basically reflect about the imaginary axis, and we'll get to the coordinate. So let's see which one matches. So reflecting the point representing z in the real axis. No, we are not reflecting like that. We are reflecting like this. So no, it can't be that. Rotating the point representing z anti-clockwise about the origin by 90 degrees. We don't know, like, if we don't know the angle between these two, so I'm gonna leave that for now. Reflecting the point representing z in the imaginary axis. Yeah, that's what we want. So we are reflecting across the imaginary axis. Yeah, option C seems good. So question 6. Let z equals to 3 plus ki, where k can be all real numbers. A value of k that makes that purely imaginary is. Okay, so let's define z in our CAS and we'll go from there. So z equals to 3 plus k times I. Okay, and now we just type the expression out that is given. So z squared plus 4 times I times z, okay, plus 3. Okay, we want the solution to be purely imaginary. So this part over here is the real part of the solution, and this part over here is the imaginary part of the solution. Now if we want the solution to be purely imaginary, we have to make real 0, right? Because if real term becomes 0, the only thing that's left is imaginary solution. And that's what the question is asking us for. So let's solve for when the entire real component, which is this, is equals to 0. So k equals to minus 6 or k equals to 2. So let's see. So k equals to 2 seems a answer that we can take. So let's do that. Okay. Question number 7. A solution to a differential equation. This can be found using. Right. Okay, so cosine of x minus y would be cosine of x cosine of y plus sine of x and sine of y. Now this is again given in your formula sheet, so if you can't remember it on top of your head, no stress, you can still find it in the formula sheet, okay? And then we have to do cosine of x plus y as well, so that is just simply the sign is going to be flipped, so cosine x cosine y negative sine x sine y. And we are doing this, so cosine of x minus y take away cosine of x plus y. So basically we are copy paste, we are doing that, take away the whole thing here, copy and paste. Well, yeah, you get the point, right? I can't fit it in, but anyway. Okay, so if I were to subtract this, these terms would be gone. So that leaves us with 2 sine x sine y. Okay, so let's erase all of this up to get some more working out space. Okay. Now one thing I do notice is that the 2 here is always with dx, so we'll keep that in mind. Okay, and I guess now we can express dy dx as e to the power of x times e to the power of minus y, or maybe I can write ey like that, e to the power of y, and times by 2 sine of x and sine of y. Right? Now we just have to collect the like terms together, so all the y terms will be with dy, and all the x terms would be with dx. So let's do that, and of course we have to keep 2 with dx, so we'll do that. Okay, so ey divided by sine y dy, integrate that, equals to ex 2ex sine x dx, integrate. Oh, and 2 is going to be outside the integrals because it's a constant, so it makes sense. Okay, so let's see which option matches. So not A, not B, C. Okay, so consider the differential equations this, where y0 is equals to that. When Euler's, I don't know how to pronounce his name, I'm just going to say Euler's method, is applied using a step size of h, where h is 0 and y3 is this, the value of h is. Okay, so for this question, I feel like just using the trial and error method would be the fastest, in a way, we could just take h equals to whatever the options are and then substitute it in and then see which one gives us y3 equals to that. So we can do Euler and we'll just type the things in. So we'll have x times y squared, comma x, comma y, comma 0, comma 3 times h. Now why is it 3h? Is because, well, y3 returns the value, right? So it's going to be 3. If it was y4, then we'll do 4h, and so on and so forth, okay? Comma 1, comma h. So I'm going to go from option D all the way to option A, because when I used to do VCE, we had like options A, B, C, D, and E, so we had E as well. And usually the answers were C, D, or E, like most of the time. So I think if you're doing trial and error method, make sure you always go from bottom, making your way to the top, okay? So I'm gonna say h equals to 0.36. No, that does not quite match the value, so it can't be that. Maybe 0.2. Yeah, that's it. This is the value. So answer is gonna be C for this question, okay? Okay, so question 9. The length of the curve specified by x equals to this, y equals to this, where t is between 0 and 2 pi is given by that. Okay, so let's write down the parametric form first of the integral. So we'll have 0 to 2 pi square root of dx dt squared. So if I were to just differentiate menu for 1 minus cosine of x, so it's sine of x, so we have dx dt is going to be sine x, and square that, plus differentiate the y to find dy dt, so x minus sine of x, 1 minus cosine of x, so 1 minus cosine of x squared dx. Well, has to be dt everywhere I wrote x, it has to be t and t dt. So it can't be option B for sure, right? Okay, so again, rather than simplifying the entire square root, I feel like just using the trial and error method would be best. So what I'm going to do is I'm going to evaluate this integral over here to get the actual arc length, and then I'm simply going to be solving integrals from A, B, C, A, C, and D, and see which one matches the correct answer. So let's do menu for 3, and we do 0 to 2 pi. We do square roots of sine of x squared plus Control C and Control V. Come on. Like that. Okay. Squared and dx. Okay, so 8. Now let's try option D to see if we get 8 when we substitute that integral in. So menu for 3, 0 to 2 pi, and then square root of, square root of 2 times cosine of t dt, t on 2, like that. Oh, there's no square root. What am I doing? 2 times cosine of 2. Okay, no. So can't be option D. Let's try option C now. So that has 2 times. Okay, fantastic. 1 minus cosine of t. Okay, can't be that either. We want 8. So it can't be option B now. Let's try option A. So that is simply changing from cosine to sine. 8. Yeah, so option A is our answer. Okay? Let's go to question 10. So the curve defined by the parametric equations this, okay, is rotated about the y-axis to form a surface of revolution. The area of this surface is, okay, well, so we just have to use the formula again from the formula sheet and just solve for the integral. Okay, so our integral is going to be menu for 3 from 0 to k, 2 pi times x, which is phi times t, and then we'll do square root dx dt and whole square. So differentiate 5t, we get 5, and square that, so 25 plus dy dt whole squared, so that'll be 12 squared, which is 144, and dt, so 65k squared pi. So it looks like our answer is going to be A for this. Okay. The velocity time graph of a particle moving along an east-west line with a velocity v equals to this, at t equals to that. Okay. Starting from fixed point origin O is shown below. The graph comprises of 2 straight line segments. The initial velocity of the particle is 40 meters second to the east. How far in meters is the particle to the east of O 150 seconds later? So we are given the velocity time graph, and how do I connect velocity time graph with displacement? Well, the area under the graph is going to be the displacement, right? Okay, so let us calculate the area. So we will make sure that we calculate the signed area and not the total area. So what does signed area mean? So signed area is basically like if it's above the x-axis, then that's considered as positive. This is if it's lower than the x-axis, it's considered as negative area. So that is your signed area. And total area is basically when everything is just positive, regardless of where the area is. But since we are finding a displacement, it is a vector quantity, therefore it will have a direction. So we have to calculate the signed area and not the total area. So let's do that. So the area above the x-axis is going to be positive, and this is simply a right angle triangle. So if we can find the x-intercept of this line, we can find the area of the triangle, right? Okay, so let's find the x-intercept of the line, but before that we have to find the gradient of this line, right? So m is equals to y2 minus y1, so 40 minus 20 divided by 0 minus 100. So where m is going to be minus 60 on 100. So that will be minus 60 on 100. So that is like minus 3 on 5. Okay, minus 3 on 5. So y equals to minus 3 on 5x plus the y-intercept, which is 40. Alright, now let's find the x-intercept of this line. So solve minus 3 on 5 times x plus 40 equals to 0 on x. So x is going to be 200 on 3. So this over here is going to be 200 on 3 and 0. Okay, so now that we know the x-intercept, we can easily find all the area that we need. So area is equals to half times the base, which is 200 on 3, times the height, which is 40, I believe. Yep. And then take away half times, take away half times 150 minus 200 on 3. So that's the base times 20. Okay, so this area over here is this over here, and this over here, this area is this over here. Okay, so let us calculate this on our CAS. So it is 112 times 200 on 3 and times by 40. Okay, and then we have 102 times 150 take away 200 on 3, and then times the whole thing by 20. So that take away that is 500. So our area is going to be 500, and that is option B. Okay, hopefully this makes sense. Alright, so next question. The position x meters of a particle moving in a straight line from a fixed origin at time t seconds is given by this. The acceleration of the particle in meters per second squared when x equals to k plus 1 is. Okay, so this is our position time function, and how do I actually go from position time to acceleration? Well, we have to differentiate it twice, right? So if you differentiate position vector, you'll get velocity vector. If you differentiate velocity, you'll get acceleration. So we have to double diff the position equation over here in terms of time. Okay, so let's find the acceleration now. So menu for 1 x, and menu for 1 x again. So e to the power of k minus 1 times x. Okay, so this over here is our acceleration, and now we have to substitute the time to find the acceleration. Okay, so we are given that we have to find the acceleration when x is equals to k plus 1, right? So we can substitute x into here to find the time, right? Because the time will be the same regardless if we are finding velocity or acceleration, right? So let's use that to solve for the time. So solve k plus 1 is equals to this whole thing over here, and then comma x, outside, inside. Okay, so this is the time taken basically to get to x equals to k plus 1, and this is our acceleration. So let's substitute that time into the acceleration to get our answer. So this will be our acceleration when x equals to k plus 1. Okay, so let's see if this matches an option. So k minus 1 whole squared and k plus 1. Right, it's not matching. So it's k squared minus 1 times k plus 1. And wait, what if I type it in? Maybe they're like same thing in different form. This one. And then times it by k plus 1. node. Okay. Where have I made my mistake? Oh, actually, never mind. I think I know. So, k minus 1 whole squared, k plus 1 is what our calculator gave us. So, if I were to expand this, so k minus 1, and k plus 1. So this over here will make it k minus 1 times k squared minus 1. So it looks like our option is going to be C. Our answer is going to be C for this. Well, I didn't see that. But anyway, okay, at least we realized. So if the angle between the vectors this and this is that, then find the value of m, where m is all positive real numbers. So in that case, let's define our vector. So define A, so that is equals to 2, minus 1, 2. Okay, then define B equals to 2, n, 6. Oh, I didn't put the brackets. 2, n, 6. And okay, and then we are just going to use the cross product for this. Okay, so let us, because we know that cosine of theta is equals to A dot product B divided by magnitude of A times magnitude of B, right? And then we can use that to find our answer. So let's do that. So dot product of A and B divided by magnitudes of A times magnitude of B. Okay, so we get this over here. Now we can just simply solve. That is equals to 13 on 21, right? Because cosine inverse, because the angle is equals to cosine inverse of that. So, okay, and yeah, so m, and then we know that our m is between 2 and 5, so 2 less than or equals to m less than or equals to 5, because that is the options basically. The options are 2, 3, 4, and 5, so it has to be between 2 and 5. So m is equals to 3. Okay, so answer is going to be B. Consider the vectors r and s, where magnitude of r equal to 9 and s is this. If the vector resolute of r in direction of s is equals to this, then the scalar resolute of s in direction of r is equal to. Okay, so vector resolute is equals to r, not dot on top, alright, so r dot product s divided by magnitudes of s whole squared and s. And that has to be equals to minus 4i plus 4j minus 2k. So let's find the magnitude of s and square it. So we'll have 4 plus 4 plus 1. Well, that's the magnitude of s, by the way. And if we square it, we are just going to get 9. So magnitude of s whole squared is equals to 9, right? So we have r dot s over 9, and that is equals to 2i minus 2j plus k is equals to minus 4i plus 4j minus 2k. So in that case, we can say that over 9 2 is equals to minus 4, right? Because we are just matching the I. We're going to do the same for the j and k component, but since it's multiplied by just a scalar, then it has to be the same one. Okay, so solving for r dot s, that will give us minus 4 times 9 on 2, right? And that will give us minus 18. So our r dot product s is going to be minus 18. Okay, and using this information we can find the scalar resolute. So scalar resolute is equal to r dot s divided by magnitudes of r. So we already have the r dot product s, which is negative 18, right? So it will be negative 18 on the magnitude of r, which is given to be 9, so that will be minus 2. Okay, so answer is going to be B. Alright, the position of a moving body is given by RT equals to that, where t is measured in seconds for t is greater than or equal to 0. The motion of the body can be described as moving along a parabolic path given by. Okay, so in that case, let's do this question on CAS. So let's graph that. I do right click, graph, enter it, and do parametric. And now just type the components in. So x component is sine of t, and y component is cosine of 2 times t. Okay? And graph that. Okay. So we have a parabola. So let us actually see the motion of this. So if I do that, if I do trace, path plot. Okay, so it's starting from 0 and 1. Okay, so let's write that down. 0 and 1. Okay, and then if I start the animation, okay, so it went to 1 and negative 1 first. I'm going to write that down as well. So it went to negative 1 and negative 1 first. 1 and negative 1 first. And then it is going to the other side now. Okay, so then went to negative 1 and 1. Negative 1 and negative 1. Okay, start the animation. Okay, and then at t equals to 6.28. So I guess that's 2 pi. So at t equals to 2 pi, it came back to 0 and 1. And then at t equals to 2 pi, it came back to 0 and 1. Okay, so I've written the entire motion down, and let's see if we could find the answer just from this information. So let's start from option A. Y equals to 1 minus 2x squared, starting at 0 and 1, reversing in direction at this. Then again, okay, so reversing in direction at 1, negative 1. Yes, so it's starting at that. That's good. So we have that. Okay, and then reversing direction at 1, negative 1, which it does go. Okay, and then again at negative 1 and negative 1. Yes, and then returning to 0 and 1 after 2 pi seconds. So far, A is the best one because it does match the description of what we just saw. And then let's try B. So y equals to 1 minus x squared starting at 1, 0. Okay, that's already wrong. And then y equals to 1 minus 2x squared starting at 0 and 1, reversing direction 1, negative 1. So far all good. Then again at negative 1, negative 1. That's correct as well. Then returning to 0 and 1 after pi seconds. Well, no, it doesn't return to 0 and 1 after pi seconds. It finishes everything and then comes back to 0 and 1 after 2 pi seconds, right? So I don't think it's going to be C either. And D, y equals to 1 minus x squared starting at 1 and 0, reversing. Yeah, okay, it doesn't start at 1, 0, so it can't be option D. I think it's going to be option A for this. Okay? So question 16, particle 1 has a position vector this, and particle 2 has a position vector this, where t is measured in seconds, okay, where t is between 0 and pi on 2. The number of times the velocity of particle 1 is perpendicular to the position vector of r2 during the first pi on 2 seconds is. Okay, so in that case, let's define the vectors. So I go here and define r1 equals to cosine of t, sine of t, and square root of sine 2 times t. Okay, and then define r2. R2 equals to, I mean, it's the same as r1. There's only a little change that it's going to be sine t and cosine t. So sine and cos switches to sine, switches to place sine and cosine. Everything else is the same. Okay, so enter. Now the question is asking the number of times the velocity of particle 1 is perpendicular to the position vector of r2. So how do I find velocity vector? So this r1 is the position vector, right? So in order to differentiate it, I'll get the velocity vector. So let's differentiate that. So mu for 1, r1. So this is our velocity vector. And for the velocity vector of r1 and position vector of r2 to be perpendicular, the dot product has to be 0, right? So let's do that. So dot product of this vector and r2. Okay. Solve for when that is equals to 0, comma t. And we know that our t is between 0 and pi on 2 and pi on 2. So it only gave us one solution. That means that happens only once. So the number of times, so it's not asking for when it happens, it's asking for number of times it happens. So since there's only one value of t when the velocity vector is perpendicular to the position vector, the answer is just going to be A. It happens only one time, right? So consider the following parallel lines. Okay, find the shortest distance between L1 and L2. In that case, let us define our vectors again. So define R1 is equals to 1 plus S, and then 3 plus S, comma, 1 plus S, right? So that's our R1, okay? And then define R2 is equals to -2 plus T plus, comma, 1 plus T, comma, 3 plus T. Enter. So let's do R1 minus R2 to get the vector, the distance vector. So R1 equal to R2. So this is the vector that we'll get if we subtract R1 from R2. So that will give us the difference between the position of R1 and position of R2. This is why we did that. And now if I was to do a dot product of this vector and the direction vectors of line 1 and line 2. So direction vectors are these over here. So just that and that. We have R1 and R2 defined again here. And we will find, so difference between the position of R1 and R2 at any given point is basically determined by R1 take away R2. Now, if I were to take the dot product between R1 minus R2 and then times it by the, and take the dot product of this vector with the direction vector that I just highlighted, we will, and then set it equals to 0, right? Because the shortest distance between two parallel lines occurs when the distance is perpendicular, right? So we have to basically make sure that this vector and dot product between this vector and both of the direction vectors has to be 0, and then we can easily get the value of S and T that way to get the magnitude. So let's do that. So dot product of this vector, and it appears that the direction vector are the same for both lines. So it's just 1, 1, 1. So this is our final answer with the dot product. Now if I were to solve this, set it equals to 0, so since both of them are equal, so because the direction vectors are the same, this will be only one equation. So we will most likely get a general solution out of this. So yeah, there you go. So this is our general solution, right? Now if I were to substitute, so basically what we found is that this is us setting the dot product equal to 0, right? This is to get the perpendicular distance. So we found the value of S and T when that happens, but it's a general solution. Although sometimes if we do substitute in general solution, it does give us a value. Okay, so There you go. This is the vector, the perpendicular vector that determines the shortest distance between R1 and R2, or between two lines. Now we're going to find the magnitude of this, so let's calculate the norm. There you go. So root 14 is the magnitude, right? So our answer is going to be B. Now if I were to give you a quick visual, so let's draw two lines. Okay? L1 and L2. Now, if I were to find a shortest distance, this is when the shortest distance would occur, right? When both of them are perpendicular, right? So, what I basically did was, I first found what this vector is, which turned out to be, let me go back to the CAS, where is it? Which turned out to be this over here, okay? And then I took the dot product of this vector with the direction vectors. So with this vector and this vector. Now, say that this vector were to be different, you can, you have two equations to solve. So, say for example, if this was 2i, right? Then our first equation would be r1 minus r2 vector that we found, okay? And then dot product 2, 1, 1. And then our second equation would be r1 minus r2 dot product 1, 1, and 1. Okay? And this would give you two equations to solve for the value of s and t. Okay? But since the direction vectors are the same, what I decided to then do is to take a dot product, like I did here, and then set that equals to 0, because we are finding the perpendicular distance, and perpendicular distance occurs when the dot product is 0, and then we are finding s and t. Now, of course, we only have one equation and we have two variables to find, so it gave us a general solution. However, when I substituted the general solution back into the vector, the r1 minus r2, it did give us a vector that determines the shortest distance. Now, to find the magnitude of that vector, we just have to do norm and we'll get it. Okay? So that's the whole procedure. Hopefully that made a bit more sense. Okay? So question number 18. The point of intersection of the line this, where t equals to that, and the plane this is. Okay, well, so our x would be 1 minus 2t. Our y would be 1 plus t, and our z would be minus 2 plus 3t. Now we just have to substitute that here, okay? And then we'll find the value of t, and then of course we'll find the point of intersection. Let's do that real quick. So let's substitute that in. So we have 3 times, let's solve, 3 times 1 minus 2t minus 2 times 1 plus t plus 4 times minus 2 plus 3 times t. That equals to 0 or t. Okay, so t equals to 7 on 4. And now, if I were to substitute that back in to this, so 1 minus 2t, so 2 times t, and substitute that in. So minus 5 on 2. Okay, I mean, this is meant to be the initial coordinate, but it doesn't match anything. So our t value is possibly wrong. Let me see what I've done wrong here. So 1 minus 2t, 3 times that, take away 2 times 1 plus 4t, yeah. And then equals to 5, not 0. What am I doing? Yeah, I think that's the mistake. I'll do that. So t equals to 3. Now, if I were to substitute t equals to 3, it will give us negative 5. So that's our first, that's our x. Now let's do the same for y. So 1 plus t equals to 0. So 1 plus t and t equals to 3. That, and then the last one, minus 2 plus 3 times t, and then t equals to 3. So our coordinate will be -5, 7, and -5, 4, and 7. So I think this should be option D over here. When conducting a hypothesis test, a type 2 error occurs when? Okay, so type 2 error is basically saying probability do not reject HO given that H0 is false. Or you can say H1 is true. H1 is true. Either of them works. So you can say, so type 2 error is basically probability that do not reject HO given that null hypothesis HO is false, or you can say given that alternative hypothesis is true. So let's read the options now. So option A, so a null hypothesis is not rejected when the alternative hypothesis is true. I mean, that sounds like the answer, right? So a null hypothesis is rejected when it is true. No. A null hypothesis is rejected when the alternative hypothesis is true. No. A null hypothesis is not rejected when it is doubtful. I don't even know what option D is. I'm just going to go with option A. Option A sounds the best, okay? So question number 20. The masses of avocados in a crop may be assumed to be normally distributed with a mean of 200 grams and standard deviation of 7.5 grams. After an avocado of mass m grams is peeled and the stone is removed, the mass of edible flesh is given by F is equals to 0.7 m. 4 avocados are randomly selected from the crop. What is the probability, correct to 4 decimal places, that a total of more than 570 grams of edible flesh is obtained? Okay, so let us find the mean first. So E of F, which is same as E of 0.7 m, which is same as 0.7 times EM, which is equals to 0.7 times 200, and that is equals to, let's do some cash, so 0.7 times by 200 is 140. So 140. Now we have to find this standard deviation. Or actually, let's just calculate the variance, because 4 avocados, so it will be like avocado 1 plus avocado 2 plus avocado 3 plus avocado 4. Yeah, okay, so let's calculate the variance. So variance of F is equals to variance of 0.70 m, which is same as 0.7 squared variance of m. I mean, we don't quite have the variance of m, but we do have standard deviation, so we just square that. So 0.7 squared times 7.5 squared. Let's do it on CAS. So 0.7 squared times by 7.5 squared. Okay, so we get 26.5625. So 27.5625 grams squared. Now we have to remember that there are 4 avocados, right? So 4 avocados. So that means we have to times mean by 4, right? Okay. So we'll get 140 times 4, which is, I believe, 560 grams. Then we'll have 4 times the variance as well, which we found to be 27.5625 times 4, and that will give us, let's see, times 4, okay, so 110.25, so 110.25 grams squared. And so the standard deviation, so standard deviation of F is basically square root of the variance, 25, and if you square root that, 10.5 grams. Okay, now we just have to use the, it's normally distributed, right? Yeah, so now we just have to use the the normal CDF to find this, and what we are finding. So what is the probability correct to 4 decimal places that a total of more than 570 grams of edible flesh is obtained? So we are basically finding probability that flesh is greater than 570 using the normal CDF. So let's do that. So menu 552. So our lower bound is 570, upper bound is infinity. Our mean we calculated was 560 grams, and standard deviation was 10.5. So it is 0.1740. So we have 0.1704. Well, if you round it up, we'll have 5005. Yeah, option B. Okay, so yeah, that is the end of section A. Okay, hopefully all of these questions made sense. Hopefully all of you guys did good as well. And yeah, thank you guys for watching, and I'll see you in the next video. Bye bye.